Hello. Hi everyone. Am I audible, guys? Just let me know. And just let me know who all are there today in this stream. Because today is Choti Diwali. So I guess not many people might have joined the contest. So is anyone there? Do I need to keep it interactive, or can I just go ahead with the solutions and assume that most of the people would watch the recording and not the live stream? So is there anyone there in the chat? Hi everyone, just let me know if I am audible and if you are there. Okay, I guess I'll have to just verify myself if I'm audible or not. So just wait 1 second, I'll check using my phone, or just let's just check here.
Oh, three girls.
Sorry. Okay, I'm audible. So let's begin with the PCD. But yeah, before we begin, I'll tell you about our courses at TLE Eliminators. So if you are someone who is stuck at just solving one or two problems per contest, then our self-paced courses are exactly what you need. We have structured the program into 4 levels, so you can start from wherever you are: beginner, pre intermediate, intermediate, or advanced. You'll learn the most relevant CP concepts through recorded video lectures by experienced educators, followed by carefully curated practice problems, combined with guided hints and detailed video solutions that help you understand the why and not just the how. We believe in helping you build real intuition. If you need more help, then you will get instant doubt support from our higher-rated mentors, so you are never left stuck. And beyond just learning, you will enjoy leaderboards, gamified progress tracking, internal contests, and PCDs to keep you consistent. Pick the level that fits your goals and start learning today. And if you're not sure that which level is right for you, then you can watch this video to know how to choose a level. And if you're still not sure, then you can watch the level specific video, which details about the prerequisites, outcome, difficulty, and topics. All right. So let's begin now. We'll discuss the first 5 problems, that is from A to D, because there were C1, C2. Okay. So problem A was Tito is playing the hit rhythm game Osu. The game can be described by a binary string S of length n and a positive integer k, where the following will happen in order. You will choose some positions in S to protect. Then for each I in increasing order, Tito can set Si to 0 if all the following are true. Si is 1, Si is not protected, and the previous k minus 1 elements do not contain 1. More formally, 1 does not occur in S of I minus k plus 1 to S of I minus 1, or 1 if this is 0 or negative. You dislike Tato, so you determine the minimum number of positions you need to protect to force her to leave S unchanged. Okay, so what you have in this problem is that you are given a binary string, like you are given two numbers n and k, and a binary string. Okay, let's say 0 1 1 0 1, and what you can do is you can like basically protect some ones, like protect some indexes. You can choose some indexes I and protect them. Okay, so let's say you protect this one and this one. So when you give this string to the samne wala, like the opponent, he will not be able to change these ones to the zeros. Okay, and what you want is that the opponent cannot change any number. Okay, the opponent must not be able to change any one, right? So if the opponent is able to change this one, then you lose. Okay, but there is one more rule. The rule is that for the opponent to change this one, in the last k minus 1 bits, there must not be a 1. Okay, So let's say in this case, if k was equal to 3, then the opponent cannot change this one like to 0, because in the last 2 bits there is a 1 here. Okay, but what he could have done, like let's say if we did not protect him, like let's say if we did not protect these ones, if we did not protect any of these ones, then he could have first made this 1 to a 0, and he can do that because there are no ones before this, right? Like in the last 2 digits there are no ones, so he can make this a 0. Now he can make this one as 0 as well, because in the last 2 digits there is no one, so he will make this 0, and then he will make this one as 0 as well, because in the last 2 digits there is no one, so it will become 0. So basically he is able to change the string, right? Like you want that he is not able to change any part of the string, but he is able to change that. So you cannot really uh, not protect any of the bits. Like you have to protect something, otherwise he will just change them. Okay, but let's say if you protect just these two, right, then he can't do anything, because he cannot change this one, because the last two bits are not all zeros, right? So this is what the problem means, and we have to just tell the minimum number of bits to protect. Okay, so we have to tell this. Now it's, I think, pretty intuitive what's the algorithm. Like essentially, let's just take a test case. Okay, like let's take this one, or let me just make my own test case. Okay, okay, so here let's say this is the binary string and k is equal to uh, 2. Okay, so first of all, will you have to protect this one? Is it necessary? So yes, it is necessary, right? Because if you don't, then he will just change it to 0, because in the last, okay, let's take k equal to 3. It's my bad. Yeah, so he will just change this 1 to a 0, because in the last k minus 1, that is the last 2 bits, there are no ones, so you can change it. So you have to protect this, right? So you will protect this. Then do you have to protect this one? So you don't have to protect this one, because in the last 2 bits there is a 1, right? And we have already ensured that he cannot change this one, so it will be there, and therefore he would not be able to change this one, so you don't need to protect it, right? You can just leave it as it is. Then you go ahead and you come up with this one. So do you need to protect this one? Yes, you need to do that, because in the last 2 digits they are both zeros, right? So if he wants, he will just change this if you don't protect it. So you will protect this as well. Then this one you don't need to, because there is a 1 here, so you will not do that. And then this one you will need to protect, because the last 2 bits are zeros. So this is pretty simple. Like the answer is 3 in this case, of course. And I think you understood that basically each instance of 1, before which there are not all k zeros, like before which k minus 1 all numbers are zeros, like here all of these k minus 1, like both of these two and both of these two are zeros, and here let's say that they are zeros only. So all of those ones need to be protected, right? So this is what the algorithm is. Like you can just uh, iterate over the string. Like in your algorithm, what you can do is you can just iterate over this string from left to right, and just keep track of what is the last one position, right? So let's say when you are here, then you will know that the last one position was this. It was I equals to 2, and you are at I equals to 5. So since this 5 minus 2, it is greater than or equal to 3. That means these last two numbers are like zeros, right? We don't have a 1 close enough, so we will have to protect this. All right. So that's what you can do, and then you can update the last scene 1. Like when you process this, after that you can just update that the last scene 1 was here, right? So you can just give a variable which keeps track of the last one, right? So this is how the problem can be solved. Okay. Yeah, you can do a simple brute force also, because n into k will work. Yeah, right. N into k will work. So you can just for all the bits, just iterate from I minus k to I. Okay. So that will take O of n into k time. And what I told you, that keep track of the last one, that will take O of n time. Okay. Anyways, so I'll just write the code for this. Like my code was a bit different because my logic was different, but I'll just write it here. So let's keep track of last one. Let's say it is minus a big value, because we need that the first, like, okay, I'll explain. If I minus last is greater than equal to k, okay, first of all, if s of I is equal to 0, then we don't need to do anything. Then ans plus plus. And last equals I, and see out ans, I guess. This should work. Like I'm just writing it right now. Let's see if it works. Yeah, it works, I guess. I can't submit it right now, I think. But samples have passed, so I think it should work. So the entire thing is like I just keep track of the last one, right? And why did I initialize it with this huge negative value? It's because for the first one that occurs, like whenever we check the first one, we always want to ensure that we count it in our answer, right? So if I want that this condition I minus last greater than equal to k should hold, whatever the k is, I will just ensure that this last value is a very negative value. So whatever I is, it will be like it will get satisfy and ans will increment, right? So that's how you can implement this. Okay, let's move on now to problem number 2. Make it zigzag. An arbitrary array of integers b of length m is considered awesome if for all I, if I is odd, then bi less than bi plus 1 holds, and if I is even, then bi greater than bi plus 1 holds. In other words, the following inequality is true: b1 less than b2 greater than b3 less than b4, and so on. You are given an array of positive integers a of length n. You may do either of the following operations any number of times in any order. Operation 1, select an integer I and do ai equals to max of a1 comma a2 up to ai. That is, replace ai with the prefix max up to I. Operation 2, select an integer I and then decrease ai by 1. Okay. Determine the minimum number of times you need to do the operation 2 to make a awesome. Note that you do not need to minimize the number of times you perform the operation 1. Okay, so the problem is just that you have to make the array zigzag. Okay, like you have been given an array A, which is A1, A2, A3 up to AN, and you have to make this entire array zigzag. That means you want to make it so that um, A1 is less than A2, A1 is less than A2, which is greater than A3, which is less than A4, and so on. All right. So basically, you want the even elements to be greater than both of their neighbors, right? Like this. Okay. And to change the array, what you can do is either you can replace AI with the prefix max up to AI, or you can uh, basically do AI minus minus, right? For any I, you can do AI minus minus, or you can replace AI with prefix max up to AI. And basically, you want to minimize the number of type 2 operations. Like you can do the type 1 as many times as you want, but you have to minimize the type 2 operations, right? So what is the minimum number of type 2 operations? That you can do. Okay, that is the question. All right. Okay, so here actually this is a nice problem. Like even I was stuck on it for more than I would like to admit. But there is one simple observation. Like if you observe that thing, then it becomes very simple. Otherwise, you will just be lost in many greedy ways of doing it. Some of them might be right, some might be wrong. But there is one way which is very easy to prove, but not that easy to see. Like unless you have good intuition. So I'll make you see that. Okay. Like I will give you some intuition about how we come up with it. All right. So what you need to do is like you need to make the array like this, right? A1 less than A2 greater than A3 less than A4 greater than A5. Okay. So that means that you would like that the even elements are as high as possible. Like they are very large. Like in ideal situation, you want that the even elements they are very large and the odd elements they are very small. Right. That's true. So let's focus on making the even elements large. Okay. Let's just focus on making the even elements large. That is, um, just focus on trying to make these even elements, that is A2, A4, A6, as large as possible, like as big as possible. Okay. And while also minimizing the cost, right? So let's take an example. Okay, these samples are pretty useless except for this one. So let's use this one. 65, 85, 1953. 21, 79, 92, 29, and 96, right? So this is your array, and I will mark the even elements with red. Okay. So what you want is that they should be as high as possible, right, guys? Now just forget the question. Just forget the question, okay? For now, and just tell me that, like, you want to use this operation, like you want to use these two operations, and I tell you that they have no cost also. Like, you can do this operation as many number of times as you want. Okay, you have no restriction on that. Like in the question, they are saying that you want to minimize the type of operations and all that. But for now, I am saying to you that you can use these operations as much as you like. Okay, and your entire goal is that this value right here should be as big as possible. Like just don't care about the other elements. They can be as small as large as you want, but this element should be as large as possible. And while, like, and you can use this operation also any number of times. Then just tell me that what is the maximum possible value of this element, like what is the possibly maximum value that you can make this. And if you can make it as large as possible, like you can say infinity also. So just tell me that just using these two operations any number of times, what is the maximum value that this element can reach? '85. Steve is saying 96. So Steve, just let me know the operations. Okay, 85. Yeah, so 85 is correct, because see, um, 85 can be made when you just apply the prefix max operation on this array. Like on this prefix, if you just apply the prefix max, ai is equal to prefix like maximum of a1 to ai. If you apply the operation 1 on this prefix, then this will become 85, right? And of course, it cannot be more than that, right? It can't become more than that, because if you do the operation number 2, if you do this operation, then it will decrease the number only. Like this can decrease the number. So if you decrease any number, like in this prefix, if you decrease any number, then of course you cannot make more than 85, right? So the best thing you can do is make this 85, right? Using one operation 1, like using operation 1 once, right? Um, so the same for every element actually. Like the maximum that you can make this is 85. This is already 85 and that's the maximum you can make it. And this thing you can make 92 at maximum, right? And also the thing is that you can make them maximum in zero cost, right? Like you can make this element, this element, this element, this element maximum possible with zero cost, because you are just using the first operation, right? And the first operation has no cost to perform. So you can definitely maximize all the even indexes, like just make them maximum possible, and while having no cost, right? And since you want them to be large, like you want this pattern, right? A1 less than a2 greater than a3 less than a4, right? So since you want them to be large, um, and the maximum possible that they can go is that value, and you can achieve that in zero cost, so of course you will make them maximum, right? There is no harm in making them maximum. Like it can never be harmful to make the even elements maximum, right? So that's the entire point, that you can just make all of the even positions maximum first, and that is their final value. Like of course you cannot make them more than that. I just proved that you cannot make their value more than that. And you can, so that's why you can like see that that would be their maximum like final value, because it does not affect the other elements, right? So you will simply make all the even elements maximum. So the first step is that make all even elements maximum, right? And that is their final value. That's their final value. Like in the final array that you will have, that is their value. We know that thing, right? So now let's say like basically in this array, you know that what is the final value of all of these numbers, right? I mean the even position numbers. So you don't know this final value, but you know this, it will be 85. Then this would be 19. This would be 85. This would be 21. This would be 85. This would be 92. This would be 92 also, and this would be 96. So like, oh sorry. I just got carried away. You don't know these odd final values, right? Like in your final zigzag array, in the final array that you have, which is going to be zigzag, you know that these even elements will be these values, because that is the maximum possible that they can go, and we are applying zero cost in that. So if you know that this is the final value that they can go, then isn't it pretty obvious that what you need to do with these numbers? Like in the odd positions, you need that it should be less than both of these sides, right? Like here we have 92, but it should be less than this 85 also and this 92 also. So of course you will not take the maximum, right? There's only two operations. Either you will take the prefix maximum or you will do ai minus minus. But since you want to decrease this number, so taking the prefix maximum cannot really decrease this number, right? It can only increase or stay the same. So doing this operation number one makes no sense. So what you will do is just decrease this number until it gets less than both of these, right? So if you want to make it less than both of these, then of course you'll have to make it less than the minimum. So you'll have to make it less than this 85, which is 84. So you will have to decrease it 8 times to make it 84. And similarly you can do it for all the odd elements. And like if it is already decreased, like let's say that this these elements, like let's say 19, so 19 is already less than both of them, so you don't need to do anything, you can just skip it, right? So this 19 will be there, 65 also less than this, then 21 is also less than this, then 92 ko we made 84 because we wanted to be less than this 85, and then 96 ko we will make 91. So 8 operations here of type 2 and 5 here, so total 13 operations, right? So that's how you get the answer 13. And similarly you can do it for any general array. Like this algorithm is definitely optimal. And why it is optimal, I just told you, because you want to ensure that these even elements are as big as possible. So and you can make them as big as possible using zero cost also, so you will do that. And once you have fixed these even elements, like once you know that what is the value of these even elements, then you can definitely figure out the value of the odd elements. Okay, so this is what the thing is. Thank you, Hari. Is there any doubts about this? Any doubts, guys? Just let me know. I'll just show the code, and meanwhile, if there's any doubts, then you can ask. Okay. Wait, I just a minute. Yeah, sorry. I am back. So I'll just show the code, which is right here. Okay, this got hacked. Very well. I'll see what's wrong. Yeah. So this problem, make it zigzag. So I'll just show the code. So int and cnn, input the array, and then this ma variable stores the prefix maximum. Okay, and initially it is a of 0, and ans will store the sum. So first of all, I'll just make all of the odd places, like in zero indexing, odd places I will make the maximum, like the prefix maximum, right? And of course, update the prefix maximum also while I'm iterating. And um, then what I'll do is, like, I'll iterate over the odd indexes. I mean, in zero indexing, you say even indexes. That is the first index, third index, and so on. So from I equal to 0 and I plus equal to 2. So for index I will check a of I minus 1 and a of I plus 1, and whatever is the minimum, if that is less than equal to ai, because I want ai to be less than both of them, right? So the smaller one of them I will see, and if that is less than equal to ai, then I will have to decrease ai by ai minus mi plus 1. That is, I'll have to make this mi minus 1. I will have to make ai as mi minus 1. So the difference is this. So I'll have to perform the operation number 2 these many times. And that's why I'll add it to my answer, right? And then I'll print the answer. Okay, fine. So let's move ahead now with C1, unless someone has a doubt. Okay. Why is it hacked though? I don't understand. Runtime error. Okay, we will see. First, I'll explain the problem and then we will see what's the problem. I don't really get it. Anyways, so the problem is that you find yourself with two arrays of positive integers a and b. Okay, wait. Let me just see if it is visible or not. The test case is visible. Okay, it is visible, and somehow it gives runtime error on this test case. I'll see what's the problem. So yeah, you find yourself with two arrays of positive integers a and b, both of length n. You will perform the following operation any number of times, possibly none. Select an integer I and increase ai by 1. This has a cost of bi. Determine the minimum total cost to make it so that there exists two integers I and j. Okay, I understood why it got in camera. No. Okay, determine the minimum total cost to make it so that there exist two integers I and j, where I is less than j, and GCD of ai comma ej is greater than 1. Okay, so what they are saying is we have to, okay, like in this version, bi is 1 for all I. Okay, so what they are saying is that we have an array ai, like a1, a2, a3 up to an, right? And we want to ensure that um, the GCD of any two indexes, like any two means there should exist at least one pair of I comma j, such that the GCD of ai comma aj is greater than 1. Like for example, um, in this second test case, or let's say, okay, I'll explain. So we have been given this array, and we want to ensure that there exists a pair of indices I comma j, at least one pair of indices, such that the GCD of a comma j is greater than 1. That is, we just need to find two numbers. We just need to ensure that any two numbers have a GCD of greater than 1. And what we can do to ensure that is that we can take any index I and do ai plus plus, right? And in the easy version of this problem, like in C1, the constraint is that the cost of doing this is 1, right? Like you can increment any number by 1, and the cost of doing that is 1. And you want to find out the minimum cost. What is the minimum cost to do that? Right. So one thing that you might notice is like one thing that you might notice instantly is that, let's say in your array a1, a2 up to an, if you have two even numbers, if you have at least two even numbers, then you can just choose them, right? Because if you choose them, then they will have a factor of 2, right? So the GCD will definitely be a multiple of 2. Okay, so this is what the thing is, that if you have two even numbers in your array, then you can just choose them and the GCD will definitely be a multiple of 2, right? So let's say you don't have two even numbers. Let's say all of them are odd numbers. Okay, in your array all are odd. Then you can simply you can always do this. You can always do what? You can always choose any two numbers and make them even, right? Just add +1 and +1 to both of them, and they will be even, right? Because they were initially odd, so finally they will be even, and then that will satisfy the condition. So the answer would be 2 in that case. Like, I mean, what I'm saying is you can always do it in two moves at most, because if there are already two even numbers in the array, then you can just choose them and the answer would be 0, right? And let's say there was only one even number, then you can simply choose one of them, and you can take any odd number and increase it by 1, right? And so that will have a cost of 1. Like, so in that case the answer would be at most 1, right? Either it would be 0, or if not 0, then in the worst case it can be 1, because you are able to find a method for 1, right? And if there are no even numbers, then the answer can be at most 2. The answer can be at most 2, because we can just choose any two numbers and make them even, right? So this is what you can observe. Okay, so now what is the so what's left now? Like, we know that ans is definitely less than equal to 2, so we want to know that whether the answer is 0, whether the answer is 0, whether the answer is 1, or whether the answer is 2. So only three possibilities are there, only three are the possibilities. So we want to check whether, like, what is the answer. So if ans equal to 0, ans equal to 0 means that in the given array, there are already two indices, ai and aj, such that their GCD is greater than 1, right? That's what it means, that if your answer equal to 0, that means they are already there in your array. So how do you check if there are two indices in your array whose GCD is greater than 1? That means they have a common factor. AI and AJ have a common prime factor. So, like, how do you check if there are two indices such that the numbers there have a common prime factor? So how do you check that? So actually it is pretty easy. How you can do that is you can simply prime factorize each number. Like, you can see that the numbers are up to only 2e5, right? 210 to the power 5. So you can prime factorize each number, and and then what you can do is you can check that what is the frequency of each prime. Like, see, basically you have an array, right? let's say you have an array 13, then you have a 6, then you have, let's say, 20, and then let's say you have 15, right? So you will write, like, basically you will write this array as 13, then 2 into 3, then you will write this one as 2 square into 5, and you will write this one as 5 into 3, right? So you will do this, and then for each prime, like, okay, you will consider this 2 square as 2 only. Like, you will just say that, okay, in this number the primes 2 and 5 appear, right? In this number the primes 3 and 5 appear. In this number the primes 2 and 3 appear, and in this number the prime 13 appears, right? So then what you will do is, for each prime, like, you will make a map. You will make a map from int to int, and basically you will store that for each prime how many sets is it occurring in. Like, simply you have factorized the number, and then for each prime that is there in this number, you will increment its frequency, right? So basically, in this example, the final frequency of 2 would be 2 because it is occurring here and here also. Then the frequency of 3 would be 2 also because it is occurring here and here. Then the frequency of 5 would be 2, and the frequency of 13 would be 1, right? And all we want is a pair whose GCD is greater than 1, right? So that means you can just choose any two positions which have a common factor, right? So if any prime's frequency, if it is at least 2, like if the frequency of a prime is greater than or equal to 2, that means it appears at two positions. Then you can just choose those two positions. Like, this 5 appears, like this frequency of 5 equals to 2, right? So this 5 appears in two positions. So you can just choose these two positions. It appears here also and here also. So basically you are sure that these two numbers ka GCD is greater than 1, right? So the sufficient condition here is that the frequency of some prime, should be greater than or equal to 2, and if that is, then the answer equal to 0. Okay, is it clear until here, guys? Like, when is the answer 0? When the frequency of some prime is at least 2. Okay, clear, guys? All right. So what else? Like, now let's say we know that the answer is not 2. I mean, all the primes have frequency of 1. Okay, like, all the primes that are there, they all have frequency 1. Okay, so the answer is not 0, definitely. So how do we check if the answer is 1? How do we check if the answer is 1? So the thing is that if the answer is 1, then what does that mean? That means that we have chosen an index, let's say AI, and we have incremented it, AI plus 1, right? And this is the only index that we have incremented, right? Like, we have chosen this index and we have incremented it, and since the answer is 1, that means we have only done one operation. So this is the only index that we have incremented. So therefore the other number aj will be as it is, right? So we will have that GCD of AI plus 1 comma aj would be equal to, like, would be greater than 1, right, for some ij. So if ans equals to 1, that means we have chosen some index and incremented it, and chosen some other index also, right? So now how do we actually check if answer can be 1? If this is the fact that we know, that if answer is equal to 1, then like, we'll have AI plus 1. So how do we actually check the fact that whether or not it is possible? So my idea is that you can simply iterate over this position. Like you can simply iterate over this I. That means you for every I, like for every I from 1 to n, you can simply check that if you increment that AI, like if you make that AI to AI plus 1, then does that have a common factor with any other number in the array? Okay, so how will you check that like efficiently? You can simply check that by making a map. Like, see, first of all, there is this nice fact that AI and AI plus 1 don't have any common factors, right? That is a pretty obvious fact. Like two consecutive numbers definitely um, don't have any common factors, right? So the thing is that what I can simply do is, like, I have the map, right? I had this frequency map of primes, like how many times is each prime occurring, right? So let's say we had this array. Um, let's suppose we have this 2, not 6, 9, and let's say we have 5, right? And we want to check that if we increase this 2, then can we get a prime or not? Like, sorry, if we increase this 2 by 1, then does that have a common factor with any other number? So of course you can check any every other number and do it in n square, but that will give TLE, right? So the optimal way to do it is just use this map, this frequency map that we have. Like in this case, what is the frequency? So frequency of 2, that is 1. Frequency of 3 is also 1, and the frequency of 5, that is also 1, right? And finally, what we can say is that, okay, let's say if for this index I want to check, like here I is equal to this, that is, I want to check that if I increment this value, then do I get any other number which has a factor with this? Okay, so for that, what I'll do is I will increment this, so it will become 3, right? Then I will prime factorize it, so it will have the prime factors 3 only, right? And then what I can just check is that do I have 3 in my frequency array? So in this frequency array, do I have this 3? So if I have this 3, then definitely some number must have given this 3, right? That means that some number must have that 3 in it. Okay, that's what it means, that this 3 must be there in some number, and also that number must not be this I, right? I mean AI, because AI plus 1 contains 3, that means AI does not contain 3. So we don't need to worry about that what if the 3 came from this one, but now we have changed it, because that won't happen. So the entire point being that you can simply increment this AI and make the prime factorization, and for every prime just check that is it there in the frequency map, and if it is there, then that means that some other number must also have that prime factor, and therefore you can simply increment this index and choose this index and that other index which has that prime factor, and therefore your answer is 1, right? So you can just try this for every index, that if you, like, for every index I, just check that if you increment this index, can you get a pair, right? That's what you can do, and that's how you will know that if your answer is 1. So if your answer can be 1, then you will know that your answer is 1. Like at this step you will know, and otherwise of course the answer is 2, because the answer can't be more than 2. That's what we proved. Okay, why we need common factor? Because that's what, sorry, because that's what the condition is. That, like, the GCD of AI comma ij has to be greater than 1. Like we need two numbers, right? We need two numbers such that their GCD is greater than 1. So GCD greater than 1 means a common factor must exist. Like that's what it means, right? Why I got runtime error in test 21? That was because in my code, like I'll just show my code now, and if someone has a doubt, then they can ask. All right. So I'll show my code. So in the code I got runtime error. I'll tell you why. So what I was doing is like I am using that LP array for factorizing. Okay. Like this LP array is what? It's just a method of factorizing. Like LP of I will store a prime factor of I. So if I want to factorize some number, then I can just keep dividing that number by that prime factor. And like basically this is the sieve of Eratosthenes. Like I'm just using sieve to factorize that number. And if you guys don't know how to use sieve to factorize numbers in O of log n, then I would recommend you to learn that. Okay, it is very useful. So I just made this sieve in main function. So LP of I, like LP of some number will store its highest prime factor, and I'll use that to factorize it. Okay. So what I'm doing is int n c in n, input the array and the frequency map, and for every number what I am doing is just finding out that what primes are, like what primes are there in that number, right? So in AI, what primes are there? So I'll temporary variable I'll use LLT equal to AI. While t is greater than 1, I will insert, like I have a set here which will contain all the primes that are there in this number. So I'll insert LP of t, that is the prime factor of t, and I'll divide the t by the prime factor of t. So in the end, I will have all the prime factors that are there in T. I'll have all of them in S, and then for all the primes, I'll increase the frequency. Right? I'll increase the frequency, and finally, I'll just check if any frequency is greater than 1. That is, if it is at least 2, and if any frequency is at least 2, then I'll see out 0 and return. All right. And so at this point, if my answer was 0, then I would have known. But now let's check for answer equals to 1. So answer equals to 1 means that I'll iterate over all the indexes, and I'll like factorize AI plus 1. Okay, I'll factorize AI plus 1 and insert all the prime factors in S again, same method. And then for all the prime numbers in X, for all the prime numbers in, like in this AI plus 1 ka factorization, for all those prime numbers, um, if it exists in my frequency map, that means some other number also has that prime factor, and therefore we can simply increase this index and choose the other one also, and the answer would be 1, right? So I'll just do this for I'll do this for all indices, and if it still doesn't satisfy, if I still can't find any index, then the answer is simply 2, right? So that's the entire thing. And the reason I'm getting runtime error in this, because I just made this LP array too short. Like I have made it of length uh, 2 2 into 10 to the power 5 plus 1. That means the last index is 2 into 10 to the power 5. But what I am doing is, like if AI, like AI can be up to 2e5, right? AI can be up to 2e5. And if I'm trying to factorize AI plus 1, when I'm trying to factorize AI plus 1, that is 2e5 plus 1. So in that case, this LP of t is giving me out of bounds. So I just had to make this n a little bigger. So if I just try to submit that, it should work. Anyways, any doubts, guys? This is running. If GCD is greater than 1, there exists a common factor. Uh, like, what is GCD? Like, what do you understand by GCD? Difficulty of C2, it was not that tough, I think. Like, I guess 1700 or something. I don't know, really. Like on C list, it is what? Let's see. Greatest common divisors of all numbers. Not all numbers, like they just want of any two numbers. The GCD of any two numbers must be greater than 1. So, like, if the GCD of 4 comma 6, it is what? 2, right? So that means 2 is there in both 4 and 6. So therefore 2 is a common factor. Yeah, like I don't get what's the confusion. Optimization with fixed sums and binary search? No, nothing like that. Just observation. It is still in progress. Okay. But it's not that difficult. Anyways, let's move on now. Let's move to C2. So C2. So C2 was the same problem with just the difference that in this case, the cost of increasing is different for different indices. Okay. So like the cost of increasing the ith index is bi. All right. So then the same question, that what is the minimum cost to ensure that there are two indices having a common factor, right? So this is like just observation based problem, and the observation is that let's say you have these costs. Like I'll just make a cost array. Let's say that you have an array A of length 6, right? And you have an array B of length 6, of course, because array A is of length 6. And let's say I don't tell you the array A. Like I haven't given you the array A. I just give you the array B. Okay. So can you guys tell me that irrespective of whatever array A is, what can be my maximum cost? Like array A can be anything, but I can make a comment on what is the maximum possible cost. Are you getting my point? Like if I just give you this array B and I don't tell you that what is array A, and I ask you that over all possibilities of this array A, what is the maximum possible cost? Like in the earlier case, we saw that the maximum cost was 2, right? But if I give you this B array, then what could be the maximum possible cost? Min of two smallest elements. Min of two smallest elements, that means the smallest element. Or you mean sum of two smallest elements? Yeah. So the point is that 2 plus 3, 5. The answer can never be bigger than 5. Okay. And why is that? It's because just take 4 cases for these two elements. Like an let's say you have both even numbers, then the cost is 0, right? If you have both even numbers here, then the cost is 0. Okay. If you have even number here, odd number here, then you can just increment this odd number, right? So the answer would definitely be less than equal to 3. It can be 2 also, it can be 0 also, but it is less than equal to 3 because you are able to get a 3, like a possibility of 3, right? If this is odd, this is even, then the answer is less than equal to 2, right? And if both are odd, then in the worst case, you can definitely get an answer of less than equal to 5. Like even if you aren't able to get any answer which is even less, you can definitely get an answer of 5. Okay. So in any case, the answer cannot exceed 5. Okay. That is the main observation here. That if your array is B, and let's say if it is sorted, okay, then your answer is definitely less than equal to b1 plus b2. Okay. So now the main question is just that, can we do better? Like we already know that this is the, like this we can do, we can achieve this one, but can we do better than this, right? That's the main question. So now we ask ourselves, what can be better? What can be better than this? Like this b1 plus b2 is already good enough, right? b1 plus b2 is already very small because it is the sum of the minimum two elements of the array b. So इससे better क्या हो सकता है? Maybe 0, right? 0 is definitely better than this. Or maybe a single element, like just b1. If we get b1 cost, then that is very good. Or if we just get b2 cost, or if we just get b3 cost, right? Like it might be smaller. Like okay, b1 is definitely smaller than this value, and b2 is definitely smaller than this value, but b3 might be greater than that also, but it might be smaller also, we don't know, right? I'm just looking at the possibilities, that what can possibly be better than b1 plus b2, right? So either it can be 0, or it can be only a single operation, right? And what else? What else, guys? What else can be better than b1 plus b2? Happy Diwali, Boombox. Your name checks out. What was the question? Like my question, right? I think my question only. So what I am saying is, we can always achieve this value, right? Like in the worst case also, we can definitely achieve b1 plus b2, right? But what are the other answers possible? Like can we do better? Like our aim, what my point is that we can definitely achieve b1 plus b2, right? We can achieve this value as an answer, but can we do better? That's our main aim to answer, right? Because we want the minimum value. So can we do better than b1 plus b2? And just remember that these BIs are cost. Like if you perform one move on ith index, then your cost would be bi, right? So your final answer would just look like something into b1 plus something into b2 plus something into b3 and so on. So what can possibly be better than b1 plus b2? If b1 and b2 are the minimum two values, then what can possibly be better answer then b1 plus b2. Like definitely, for example, b2 plus b3, this can never be better, right? This can never be better than b1 plus b2, because for obvious reasons, right? Because this b3 is greater than b1. So I'm thinking that what can possibly be better than b1 plus b2. So I just came up with 0 can be better, of course, like if we don't perform any operations, or it can be b1 is better, of course. b1 is definitely better than b1 plus b2, or b2 is definitely better than b1 plus b2. Then b3 also might be better. Like it depends. Just say if we have 2, 3, and 4, then here just taking b3 is better than taking b1 plus b2. All right, and so on until, like, basically bn may also be better than b1 plus b2 depending on the values. Then what else can be better? Virat Kohli, either b2 or b1 or 0, that's not true, because b3 b4 also can be better than b1 plus b2, right? Choosing one single element multiple times, yeah, that might be better. Like you are saying that maybe some bi ko we choose k times, right? Where k is at least 2, greater than or equal to 2. Because if k is 1, then we have already handled it here. Okay. But the thing is that I claim that you will never do this. I mean, you would never take uh, this bi as I greater than or equal to 2. Like, let's say my claim is that you will never take b2 twice, or you will never take b2 more than once. Okay, like 2 into b2 is already worse than this b1 plus b2, right? And you also won't take 2 into b3, you won't take 2 into b4, right? Or not even 2, maybe 3 into b3 also you won't take. So my point is that you will never take this b2 b3 up to bn multiple times, because that will already surpass this b1 plus b2 definitely, right? But what you can do is take this b1 multiple times. Okay, like k into b1, that might be possibly less than b1 plus b2 for some value of k, right? That's the point. That you, like, the entire observation was that you will never take these higher numbers multiple times, right? So either your answer would be b1 plus b2, or it would be 0 or b1 or b2, like only a single element, or it would be that you would increase the minimum element multiple times. Okay, these possibilities are only there. Like, these are the only possibilities that can be there, that either you don't do anything, or you change only one element only once, or you change the minimum element, I mean the element with the minimum cost, multiple times, right? That's the only possibilities. Or you will have your answer as b1 plus b2. These only 4 possibilities are there, and you just want to check the answer for all these 4 possibilities and just take the minimum. All right, yeah, exactly. So you will just check all of these 4 cases, and it is pretty easy to do that. Okay, so the first case is that no change, and we already saw how to handle that in the previous version. Like, we know how to check if the answer is 0, and we'll just take the same code and paste it here, right? Then second case is that single element a single element increased by 1, right? And this case also we know how to handle, right? Already we have handled in the previous one. Like, just iterate over all the elements and try to increase them by 1, and then try to factorize them. Okay, and then the fourth case is that b1 plus b2. So this is your, obviously this is the direct value, you don't need to do anything in that. But the main thing is third case. Third case is that you have the minimum cost index, that is some AI, and you want to increase it to some number, right? Like you want to add k to it, you want to make it AI plus k, such that the GCD of that AI plus k and AJ becomes greater than 1. So you want to, of course, minimize this k, right? You want to minimize the number of operations, because your cost would come out to be k into AI, k into bi, right? So even though this bi is minimum value, but still you want to minimize the answer, right? So you will minimize this k. So essentially, you just need to find out the smallest value of k for which the GCD of AI plus k and AJ is greater than 1. That is, you want to find out the smallest k such that AI plus k has a common factor, has a common prime factor with some other number, right? So that means that essentially AI plus k has to have, like, basically AI plus k should be divisible by some prime number, right? Such that that prime number exists in some other index as well. Like basically we want any prime number such that AI plus k is divisible by it, and also that prime number exists in some other index, right? For example, we had this test case here, like where we had 2, 7 and 11, right? We had 2, 7 and 11, and let's say we want to increase this 2, like this is a minimum cost, like let's assume that this is a minimum cost, and we want to increase this k times, so 2 plus k, and we want to make sure that it is a multiple of some prime which exists in other indices as well. So what are the primes that exist in these indexes? So one prime exists 7, and another prime that exists is 11. So if I want this 2 plus k to be a multiple of 7, then what is the minimum value of k? It is 5, right? It will be 7. And let's say if I want this 2 plus k to be a multiple of 11, then what is the value of k? It would be 9, right? And so the minimum value of k that you would get is 5. Okay. And so in general, you just do this, right? Like you just have an index AI, right? And you have other numbers also which have some prime divisors, p1, p2, p3, up to pm, let's say. So like these are all the prime numbers that exist in these remaining numbers, right? And you just want that this AI plus k should be divisible by some pj, right? So what you can do is just iterate over all these pi's, okay? Like all of the prime numbers that exist, just iterate over them, and then figure out that what is the minimum number of times you need to increase to make it a multiple of p. Like what is the minimum number of times you need to increase this AI to make it a multiple of p. Like let's say if you want to make this you want to make this AI a multiple of pj, then what is the number of times that you need to increase it? So let's look at a number line. Like this AI is here, AI is here, then let's say you have 1 into pj, 2 into pj, then up to let's say something k into pj, not k, let's say lambda into pj, then you have AI, and then you have lambda plus 1 into pj. So basically you need to cover this distance, right? You need to increase this AI by this much. And like, can you write this in good terms? Like in closed form, can you write? So what is this distance? This is basically the remainder of AI, right? If you divide AI by pj, then the remainder, right? So this distance is basically AI mod pj, right? So what is this distance? This distance is basically pj minus AI mod pj, right? So this is the value of k. So like for some given prime, if you want to make AI a multiple of that, then you have to increase it by pj minus AI mod pj, right? And so you will just iterate over all the primes. And for the minimum cost number, you will find out that what is the minimum value of k by which you can increase this AI, and you will get a multiple of some prime. What is the minimum value? So you will just take the minimum of this value over all the primes, right? And that's what the answer you will have for case number 3. Like you will find a k, and the cost would be k into bi. So this k you will find out by just iterating over all the primes which are there by the other numbers. Like just make sure that you don't include that prime which is contributed by that number. Like whatever is the smallest cost number, which is AI, you have to like remove those primes which are only contributed by AI. Okay. Like what I mean by that is, let's say you have 2, 3 and 7, right? Or let's say you have 2, 3 and 15. So this contributes the prime number 2, this contributes prime 3, and this contributes prime 3 and 5, right? But when you are trying to increase this number, let's say this AI is 2, like, so you are trying to do 2 plus k should be a multiple of either 3 or 5, but you don't check, like you can't check it to be a multiple of 2 because this 2 is given only by this number. So we, like, if this is a, this we are choosing 2 plus k as one index, we cannot choose it again, right? We cannot choose that again. So since this 2 is only contributed by this index, therefore we won't check for 2. Like when we are iterating over the primes, we won't check for 2, but rather we will check for 3 and 5 only. Okay, so we'll have to maintain a frequency array that how many times each prime occurs, and if it occurs only once by the smallest cost number, then we will not consider that. Okay. So we'll take the minimum value with each prime that is contributed by the other elements. So the number of primes that are less than 2e5 are at max 2e5, right? It is so easy in how why less solves. I don't really know. Probably because it can't be solved by AI, I guess. I don't know. Like the observation that b1 plus b2 से छोटे होना चाहिए. Like actually even I was a bit not on the right track initially because I did not observe that the minimum cost was b1 plus b2. And yeah, even I did not observe that multiple times you will only increase b1. You will not use the multiple times operation on other indexes. So it had some observations. It was not very easy, but yeah, let's show the code. So in the code, again, we have 4 cases, right? 4 cases are either the answer is 0, or we have single element change, or we change the smallest one multiple times, or the answer is b1 plus b2, right? So the first case, this is the first case, the same code as that we had, okay, in the previous one, just checking if answer is equal to 0. So if the frequency of any prime, for all frequencies, if the frequency of any prime is greater than 1, then the answer is 0, right? Then I have this ans variable which will store the minimum for me, the minimum of all remaining 3 cases, right? So this is the first case, I mean second case, where we increase the element only once, like we increase any element only once. So the set of int s, like I'm just trying to factorize this ai plus 1, right? So I'm incrementing this ai by 1 and I'm trying to factorize it, and if that factor exists in any of the other elements, that is in my frequency array, if that prime factor is there, then the bi is one of my possible answers. That is, I'll just increase that index by 1, so the cost would be bi. So that's my possible answer. So I'll take the ans, like I'll take the minimum with this ans, right? And finally, finally I have this third case where I will check for the the case where the minimum cost element is incremented multiple times, right? So I'll find the minimum element in the array b, and its index is it. So the value that I have is a of it, the minimum cost value, and then I'll factorize it again. So temporary variable I'm storing it, and in this set I am just storing all the factors, all the prime factors I am storing in this set. Okay. And what I'll do is I will remove the contribution of every prime factor from the frequency array, right? Because I only want the primes which are contributed by the other elements. So I will decrement the frequency of this prime factor, like every prime factor of this one, and I'll erase it from the frequency array if its frequency becomes 0, right? And then for every prime that remains in the frequency array, like basically for all the primes that are contributed by the other elements, I will take the answer, I will take the minimum with b of it, like the cost into k, where k is x minus val mod x, where x is the prime, right? So p minus ai mod p. Okay. And finally, I'll print minimum of ans comma b0 plus b1 after sorting it, right? So I think it should be fine. But I think this is also hackable. I think I can also hack this submission. Let me just try to hack this. Because the same issue, right? It should be hackable, I think. Or yeah, maybe someone already hacked. Maybe this will not pass. I did not give Meta Hacker Cup. Maybe this will give runtime error if someone already has uphacked it. Somehow in the system testing it did not fail, but right now I'm trying to hack it. I'm pretty sure someone already hacked it because the same test case is there on C1, so why can't it be there on C2? Yeah, it is giving runtime error. So somehow it passed the system tests, but after system testing, someone else hacked it. So now that test case is added to the tests, but it is not there in the contest test cases. So I'm kind of lucky. Anyways, the same mistake is there, that the n is too small. Okay, because I am trying to factorize 2e5 plus 1. So my length, like this n should be 2e5 plus 1 also. Anyways, let's try to move ahead with D. So D was, a cat lives on a tree with n nodes. The cat starts on the node 1 and you live on node n. You are going to leave the cat a note written in the Parkour language to help it reach you. The parkour language has two types of instructions. One, this means that the cat should move to any adjacent node to it. If there are multiple ones, then it will pick arbitrarily. And if there are no adjacent nodes to it, then it will not move. And 2 comma u, this means to destroy the node u and all the adjacent edges to it. If the cat is currently on node u, it will die. So this should be avoided. If the node u is already destroyed, then nothing will happen. Also, there cannot be two consecutive instances of the second instruction. Unfortunately, the parkour language is ambiguous because the cat may have multiple options for each instance of the first instruction. So, construct a sequence of instructions of length at most 3n so that if the cat follows them, it will end at node n, no matter what choices it makes. It can be shown that such a sequence always exists for any tree. Okay. So what they are just saying is that we have a tree, all right. We have a tree, and let's say this is a tree. So cat lives on node 1 and we live on node n, right? And what they are saying is we can give the cat instructions, right? Either we can tell it to one, either we can tell it to move to any square, like move to any adjacent square, right? Or we can tell it to destroy cell u. Like we can give it a cell and tell it to destroy it. Like we can give the cat a cell to destroy and it will destroy that cell, right? Or we can just tell the cat to move anywhere arbitrarily, but we cannot tell the cat where to move. Like it will choose it by itself. Okay, it's his choice. All right. So initially the cat is at 1 and it wants to, like we want it to reach 5 or the node n basically. And what we need to do is that we need to give it some instructions in such a way that the cat will end up at n no matter what it does in this instruction 1. Like whatever it does in this, it should always reach the nth position. All right. So for example, we have the samples. Like I'll just explain the samples. So we have the fourth or the third test case, 1 2 1 3 1 4. Okay, 1 2 1 3 1 4. And yeah, there is one more condition, is that you cannot give this instruction more than once in a row. Like you cannot say that okay, destroy this node, for like destroy third node, then destroy fourth node. You cannot do that. Okay, because that would make the thing very easy. Like you can simply destroy all the nodes. Like it would make it easy, just trust me. Okay, so okay, for example, in this case, what you can do is, like what you can give it the instruction is that okay, first do the move number 1. That is okay, for the cat is at 1, right? So first do move 1, that is move to any of the adjacent squares, right? So either it moves to 2 or it moves to 3 or it moves to 4, right? Then what we tell it is move again. Okay, or we can actually start with destroying. Okay, so what we can do is, initially it is at 1, right? So we can tell it to destroy 2. So destroy 2. Okay, then we can tell it, so now 2 is destroyed, then we can tell it to move to an adjacent square. Okay, so what it will do is, it will either be at 3 or it will be at 4, right? Then again we tell it to move to adjacent square, so it will again move back to 1, of course. Wherever it is either at 3 or at 4, so it will move back to 1, right? So now we can tell it to destroy 3. So now 3 is destroyed and we know that the cat is at 1, right? And then we can tell it to move, so it will move to 4 only, because that is the only option. And therefore this sequence of moves guarantees that the cat will always end up at 4. Like whatever choices it makes, it will definitely end up at 4. And also the destroying moves are not done consecutively. All right, they are not done consecutively. So this answer satisfies our conditions, and it is a valid answer. And let's say if you are allowed to destroy consecutively, like let's say the constraint that you are not allowed to do two adjacent, uh, like not allowed to destroy something twice in a row. If that constraint was not there, then it is pretty easy. Like in that case, you can simply delete this two, just delete this two, delete this three, and then tell the cat to move. So it will only move to four, right? But you cannot do this. You cannot tell it to delete two, then tell it to delete three, because that is not allowed. Okay. So this is the problem that we have to solve, right? Can we solve this using DFS? First, we do DFS to get part to node n. We add these nodes to a queue comma stack. Now, when we do DFS again, we can do 2 operations for node nothing path, else one. So you are saying that um, okay, what are you saying? Like when we do a DFS again, so just tell me that in what order will you do the operations? Like this 2U operation and one operation, like how will you ensure that you don't do two operations consecutively? Like except for sorting on B isn't C1 C2 same exactly. No, C2 has one more case, right? C2 has one more case that you can increase one element multiple times. Like in C2 we had this test case. In C2 we had this test case where you are increasing this element 5 times, right? But in C1 you will never increase an element more than once. Okay, so it is not the same. Yeah, exactly. But if you don't do anything to that neighbor, then it might be that the cat moves to that neighbor, like it goes off track, right? That might happen also, so that will be a problem. Anyways, so how do we actually do this? So like my idea is, see, I was thinking about this and I had some problems. Okay, so let's say the cat starts at one, right? And let's say one has many neighbors. So this is one of the subtrees. Like this is one of the neighbors, and that neighbor has more neighbors, and it's a tree, right? So this will also be a tree. So one has this subtree, then this subtree, then let's say this subtree also, and the node n is in this subtree. Okay, so I just want that when the cat is at here, and it should move, like when I tell it to move, it should move to this subtree, right? But what if it doesn't? Like what if it goes to either here or here? So then what do I do? So I thought then that may be okay, let's delete this node. So the cat can't go here now. But the thing is that I cannot delete two nodes consecutively. So I cannot really delete this one as well. Like as soon as I delete this node, I am compelled to tell the cat to move, right? And what if I tell it to move and it moves here? Okay. What if I tell it to move and it moves here? And then if I delete that, if I delete that node, then the cat will die, right? So that's the issue. And also, let's say if I don't want the cat to die, Okay, so let's say I make it one more time. Like what I am proposing is, first I'll delete this node, then I'll make the cat to move, but then it might be here or here also. So in case it is here, I will tell it to move again. So it may move here, and then I'll delete this node, right? But the problem is that what if it moves even inside? Like what if it moves once more inside? Then if we delete this node, then we have deleted the path to come to n. Like now it can never possibly come towards n again, right? So that is the problem. So this thing to control is very difficult. Like to control this thing, that when you are deleting a node, when you are deleting a node, let's say somehow you ensure that the cat is not on that node. Like let's say somehow you have a method to ensure that the cat is not on that node. Okay, but um, what like the thing is that it is very difficult to ensure that deleting that node doesn't cut your path towards n. Like if your cat is on this node and you delete this node, then it just cuts your path and you can never go to n now. And it is very difficult to ensure that the cat is not here. Okay, so just avoid this entirely. Like my proposal was, like my idea was to avoid this situation entirely. Like we just try that this doesn't happen. And how do we do that? We just always delete leaf nodes only. Like my idea was, we always delete only leaf nodes. Okay, so that will not cause a problem. Why? Because see, let's say we have a tree like this. So if we delete this node and we are sure that the cat is not on this node, right? Then um, we can be sure that the path to n is not deleted, because only this node is deleted, right? Like nothing else is deleted. So wherever the cat is, it can always reach n. Okay. So deleting the leaf node is our best bet. But we have to be sure that the cat is not there. Like we can delete a leaf node if we are sure if we are sure that the cat is not there, right? We can do that, but we cannot delete any arbitrary node, right? We cannot say the same thing for any arbitrary node, because it might happen that deleting that node might delete the path from that node to the node n, and it is no longer possible for the cat to reach n, right? So we can delete a leaf node only if we are sure that the cat is not there, right? And basically my idea is that we just delete all the nodes one by one, and in the end only node n will remain, and therefore the cat will definitely be on node n at that point. Like my entire thing is that somehow if we can be sure that the cat is not there, like the cat is not on a leaf node, then we can delete that leaf node, right? And that will maybe create more leaf nodes, and ऐसे करते करते we can, like, one by one, while deleting leaf nodes we can delete the entire tree except the node n. And finally, if there's only node n remaining, then of course the cat is on node n, right? The cat is definitely on node n only. That's my strategy. But the only thing that I don't know now is how do I ensure that the cat is not on that node, on that leaf node, it is not there. How do I ensure that? So that is a pretty good observation. Can you guys let me, like, do you have any idea? How do we make sure that operations don't exceed 3n? Yeah, I will make sure that, because I haven't told you right now that how exactly we will ensure that the cat is not on the leaf node. Like 3n ka though we will think about later. Let us just come up with a solution. So my idea is just that for any given tree, for any given tree, I will try to delete leaf nodes. Right. So basically, see, it is pretty obvious that you can delete the entire tree just by deleting the leaf nodes one by one, right? Like let's say this is 8 and this is 7. So finally, you want to keep this 8 node, right? You want to keep this 8 node in the tree, and all the other nodes you want to delete. So you can definitely do that by deleting the leaf nodes one by one. So for any tree, you can definitely keep one node at the end and delete all the other nodes while deleting the leaf nodes. So like you can delete this one first, then you can delete this 3 leaf node, then this 2 becomes a leaf node. So you can delete this as well. Then you can delete this 4, then this 6, then 5 becomes leaf node. So you can delete this 5. Sorry. Uh, then you can delete this 7. And finally only 8 is left. So my point is that entire, like any tree can be deleted just by deleting the leaf nodes one by one, right? And also if you have a particular thing that you want to save this node at the end, then also you can do that. You can simply delete all the other nodes one by one. But how do we ensure that the cat is not on that node when we delete it? So you guys don't have any idea, I guess, because no one responded to my question. So let me give you more intuition. Okay. So I'll just draw a tree, guys. Okay. Yeah. So I have drawn this tree for you. So the cat is at 1 initially. Okay. So guys, just tell me that after 0 moves, like if the cat has made 0 moves till now, what are the possible nodes where the cat lies? So of course it lies only at node 1, right? If we have only made 0 moves right now, then of course the cat is at node 1. If we have made 1 move, and by move I mean the operation number 1, okay, not the deleting one. So if you have made 1 move, that is one moving operation, then where can the cat be? Just tell me, where can the cat be? What all nodes can the cat be there? On what all nodes? Tell me, guys. Or is this chat not updating? Okay, it is updating, but no one is writing. 2, 3, 4, 5. Yeah, correct. No idea. I am blank. So this is a pretty simple question. Like, if the cat is at position 1, then it can be, I like, if it is currently at position 1, and if I tell it to move, then it can move to either 2, or to 5, or to 4, or to 3, right? It can only be at one of these 4 positions, right? It can't be at 1 because we have told to move from 1. So it can be either at 2, 3, 4, or 5. Okay. Then after two moves, where can the cat possibly be? That's my question. Level 2 or 0. Yeah. So basically, all of the nodes which are there at level 2, like basically either this 6 or at 7, like currently, okay, I'll just use some colors and to show it to you. So this is the 0 level. Okay. This is the first level. स्किल इशू हो रहा है थोड़ा सा. Okay. And the third level is this one. I mean, the level number 2. This one, basically. I think my drawing is making it worse, right? I'll just delete this. You guys can see that, like, see, this node number 1 is at distance 0 from 1, right? So after 0 moves, the cat can only be at node number 1. Then after 1 move, the cat can be either at 2, 3, 4, or 5. That is the nodes which are at distance 1 from the starting node, right? Then after 2 moves, either the cat would be at a distance of 2 from the node 1. So all these distance 2 nodes, right? Or it can be back to node 1. Like after 2 moves, it might happen that the cat went to this node and then back to this node again, right? And so after 3 moves, where can it be? After 3 moves, either it can be like, either the case is that after 2 moves it was at the 1, and now it can be at the level 1, right? Or it can be or at level 3 also, right? So after 3 moves it can be at level 1 or level 3, right? So I'll just write it again. After 0 moves it can be at level 0. Then after 1 move it can be at level 1. After 2 moves it can be at level 2 or level 0. And after 3 moves it can be at level 1 or level 3, right? So do you guys see a pattern here? Like after x moves, can I say that where cannot the cat be? Like any pattern can you observe that after x moves, if x is even or x is odd, then where can it be? Can you guys see a pattern? Like okay, I'll increase this list. After 4 moves, the cat can be at either level 0, 2, or 4. Okay. After 5 moves, it can be either at level 1, 3, or 5. So after this, it might be clearer, maybe. Do you guys get it? Maybe Suhani gets it because she answered the question. Yeah. So the entire observation is that after x moves, like the entire thing is that after an even number of moves, after an even number of moves, um, the cat can always be at an even distance. At an even distance from node 1. That is, after an even number of moves, the cat can always only be at an even distance from node 1. Okay. So like that's my point. That if you have made the cat move an even number of times, then you can be sure that all the leaves which are at an odd distance, definitely cat is not there, and you can delete those leaves. Like, why is it true? See, initially the distance is 0 of the cat, right? From the node 1, the cat has a distance 0. Okay. Then after it does a move, the distance becomes 1. Then after it does a move, either the distance will increase by 1 or decrease by 1, right? Because it is a tree. So the distance will either become 0 or 2. Then again, when it does one more move, either it becomes 1 or 3. So either it increases from 0 to 1, or it decreases from 2 to 1, or it increases from 2 to 3. So since at every step the distance will increase or decrease by 1, therefore I can say this, that after an even number of moves, the cat will definitely always be at an even distance node. So we can always delete an odd distance wala leaf. We can delete odd distance leaf. Okay, it's always safe to do that. All right. So basically, if we want to just delete the nodes, then we can ensure that, like, let's say if I want to delete the node 5, and I know that it is at an odd distance. Okay. Then what I'll do is I'll make sure that until now I have performed an even number of moves. Okay. Like, let's say until now I have performed 3 moves. Like, until now I have performed the operation number 1 3 times. Then I will just do it one more time, so that I can be sure that the cat is not on this node, and then I will delete this leaf node, right? Because it has an odd distance. And that's what I can do. I can just keep doing this for every leaf, and also the nodes, the new leaves that are being created. And I can make sure that in the end only the node n remains on the tree, and that's how I can be sure that the cat will definitely be on the node n. All right. That is the solution. So do you guys get the solution, or do you have any doubt? Like, essentially the solution is like, just find out an order of leaves. Okay. Like, let's say in this tree only, not this tree, this is too big. I erase that tree. Let's make a new tree. Let's say I have 8 nodes. Okay. So basically, what you can just do is, let's say you want to delete these leaf nodes in this order. Like, let's say first you want to delete 1, then you want to delete 4, then 3, then maybe 5, then maybe 6, then 2, then 7. And of course, you won't delete 8 because the cat will end up at 8. So you want to delete these leaf nodes in this order. So what you can do is just find out the distance of each one of them, and you can do it using whatever BFS, DFS, whatever you want to do. You can just find the distance from node 1 of each of these nodes, right? So let's do that. So node 1 has 0 distance from node 1. Node 4 has 3 distance. Node 3 has 1, 2, 3, 4. 5 would have also 4. Then 6 has 3 distance. 2 has 2 distance, and 7 has 1 distance, right? So basically, in this case, what would be the answer? So first of all, you want to delete this node 1, right? So node 1 has even distance. So you will have to ensure that before this node gets deleted, you have moved an odd number of times. So first you will tell the cat to move. So at this point, the cat has moved an odd number of times, that is one time. So now you can safely delete this node. So you can delete the one, right? I am denoting the circle operation, like I'm denoting the operation 2 by circle, okay? And the operation 1 is just 1. Now you want to delete this 4. That means you have to ensure that like this 4 has distance, odd distance, right? So you have to ensure that this node, like you have to ensure that the cat has moved an even number of times. So you will tell the cat to move, and then you will delete this 4. Then you will go here, you want even odd number of times, so you will tell the cat to move, you will delete this 3. So until now you have odd number of times. Then you have this. So you want that the cat should have moved an odd number of times if you delete this node. So you can safely delete this node right now, but the thing is that it is not allowed. It's not allowed to delete two consecutive, like you cannot perform the delete operation two consecutive times. So what you have to do is you have to make the cat move 2 times. Like until here it was odd, right? And you want odd, so you will make it move 2 more times, and then you will delete, right? So the entire point is that for every node that you delete, you either make the cat move 1 time or 2 times. So at most 2 times, right? So for every node, for every leaf node, you get one operation for deletion plus two, at max 2 operations, like either 1 or 2, at max 2 operations for moving. And since you are deleting n minus 1 times, so at max 3 into n minus 1 operations would be required for this. Okay. So this is what the solution is to this problem. And you can just find out the distance from the node 1 using DFS or BFS, and you can simply keep track of the in degree of each node. So whenever you are deleting a leaf node, you will just decrement the degree of all of its neighbors, and as soon as the degree of any node becomes 1, you will mark that one as also a leaf node. So it is basically Kahn's algorithm of topo sorting. The implementation is pretty simple, like you can think of it by yourself also. You can do it in maybe the order of DFS as well. Like maybe you can root the tree at node n, and then you can do a post or a traversal. For the first time, I crossed 1000 on CF, but I feel like I'm not improving much. Okay, so this happened to me when I was also like trying to improve. Like it happened to me on a higher rating, but still the same thing happened to me, that I'm not improving. I just thought so. Whatever was my rating, like whatever is my target rating, or let's say whatever is my current rating, what I'll do is I'll open CF. I will go to problem set, and I will okay, my internet. Yeah, I'll go to problem set. I'll filter this. I'll enter like let's say if I'm 1000 rating, then I'll enter 1000 to 1200. Okay, I'll hit apply, and I will solve the problems whatever appear here. Okay, I just keep solving them. If I'm not able to solve them, then I say the tutorial. Like let's say I open this problem, I try it, and I let's say I solve it, then it is fine. But if I'm not able to solve it, and like I'm making no progress, then I click this button. I just look at the editorial, and let's say if there are some like concepts which are used in this, like new structures or something, or new algorithms, then I go to Google and I just write it. Let's say one-side lemma. I just read it, and it works. So like this is what you have to repeat. This is what the practice, like this practice is all that can help you. grow rating. Okay, like no theory, nothing can help you if you don't practice. That's my entire point. Okay, like even I was stuck at 1900 rating. I was not able to get past that. If you can see, like I reached 1900 at this point, which is June 2024, and until May 2025, I was not able to cross the 2100 mark, right? So I asked someone like how to improve. So they were the one who told me that I should just solve problems, and that's what I did. Like I solved the problems of 2100, 2200, 2300, so that I can make my rating go up to 2100, right? So similarly, you should solve many problems having rating slightly higher than your current level. Okay. All right. Okay, that's fine. Like I don't really know what lead code rating means. I don't do lead code. I'm in college. I'm in third year. How to overcome fear of losing rating? I mean, what is rating, man? Like you might think that companies look at the rating, but I guess they look at max rating only, right? Max rating. So max won't decrease whatever you do, and your rating won't increase if you don't give contests using because of the fear of losing rating. Like in the end, it's just a number. Like it doesn't matter much. The only thing that should matter is the kick that you get when you see the green color. The like when you see that your code is accepted, that's like that kick that you get, that should be the only thing that matters. Okay. Yeah, no issues, Suhani. I hope you understood today's PCD well. All right. So happy Diwali, everyone. I think it is Diwali now. Like at least the date is of Diwali. I don't know how it works in Hindu calendar. DP, like you can watch this Priyanshu's video only. It is on TLE Eliminators YouTube channel. DP Bootcamp, I think that's what it's called. Like uh, I myself learned it using this video only. I just watched this video and then I solved many problems. Okay, so if that is fine for you, you can watch that, or else you can watch this entire boot camp, which happened at IIT Gandhinagar. And this is in more detail actually, but I did not require that, so I just watched that 40-minute video. सर आप इंडिया से ही है ना? हाँ जी, मैं इंडिया से ही हूँ. आपको मिलना है क्या? विभास भैया को थैंक्स एंड मुझे भी थैंक्स. ओके, यू आर वेलकम. अच्छा, it is this comment was of for the Diwali thing, right? Well, I am not very much aware about those things. I am learning. Like कल महाभारत देख रहा था मैं. But yeah. Anything else, guys? Happy Diwali. You might be. Thanks, Siddhant. Yeah, and पटाखे फूट रहे थे background में, so you might have heard some noises. Anyways, so if there are no doubts anymore, okay, I forgot to show the code, but okay, I'll share the link. The code is not that tough. Happy Diwali, Abhiram. Wow, your name is pretty relevant for Diwali. Do you know any tools which I can track my progress for CF? I don't really know that. Like, I know this tool, MyCP Trainer or something. I don't know what it provides, but you can try to use this. I think it is pretty good. Anyways, so I'll take your leave. I think you guys don't have any more doubts. I'll share the submission links under this video. And bye everyone. Good night. Shabak here. Kailash here. Bye.